is used to switch off the LED. At the same time, set B port 1.3, P 1.3. That means it is used to switch on the LED. That is depending upon which position, switch position. Every time I have to check my switch position. When my switch is open, my port value is 1. Okay, that we will check. JB, jump on bit. P2.2. P2.2 only I have connected my switch. So whenever my switch is open, my CLR command I have to put. Whenever my switch is closed, that is jump on bit, P2.2 is 0, then automatically that particular LED should turn on. But while you are turn on and turn off, that particular time delay has to be very much important. Whether my motor is rotating or the particular in traffic light system, the particular LED is glowing for particular time. For all the things, the time delay is very, very important. That's why I'm specifying time delay is the program to connect from main program to subroutine program. A call means absolute call. The absolute call will check 2 kilobytes. Okay, it will check some 2056 locations of the memory, and it will link from main program to subroutine. Okay, now you just understand this question I told you not only for the lab, it is also for concern with the theory also. Because in our lab programming, we have seen, yesterday I have shown you the syllabus, instruction, that is that addressing modes, instruction set, simple programming, IO programming, then timer delay programming. Actually, here we are not using any register to create the time delay. We use the timer to create the time delay. So this is the specific program. If your question is so specific, create the time delay, create the timer to create the time delay. Now you have to write this program. Are you clear? So don't think that it's a lab program. It's not used in the theory. All which is we are doing in the lab, it's concerned with the theory also. So you just see this is the delay program. Move T mod. Register number 7. Register number 7, ma. Amritavalli. What is T mod, ma? Sorry. Or what's your name, ma? 7. Sorry. Harshavardhan. Tell me. Harshavardhan, what is T mod instruction, ma? T mod, not what is T mod? What is T mod? Yeah, I can't able to hear, man.
T mod instruction.
T mod is not an instruction actually. I'm saying what is T mod? What is P2? What is P2? What is P2?
Move P2.
Move P2. That is, I'm asking what is P2? What is the P2 means what?
Instruction.
Instruction only. All are instruction only. I'm clearly asking what is P2?
Indicating that.
Someone is helping your friend only. I can able to hear what he's saying. Actually, port 2. Harshavardhan. That is register number 7, Harshavardhan. Okay. Kindly listen it because all the program you can't able to study. When you know the logic only you can remember. Okay. Tyagi is here. Tyagi is absent today. Okay. So now listen, ma. Okay. T mod, that is timer mode register. Are you clear? What is the purpose of timer mode register? Now, actually, the timer mode register is used to set whether it is working in which mode of operation. Here, 4 mode of operations are there: mode 0, mode 1, mode 2, mode 3. So, timer 0 is used to select which mode of operation and which gate I have to apply, whether I have to get the internal clock pulse or external clock pulse, and whether it has to work in a counter mode or timer mode. I already told counter means it will always used to increment or decrement, but timer is used to create the time delay in the program. Are you clear, ma? So timer mode register, that is used to select which timer mode I am going to use in the particular program, and whether I have to use a counter operation or timer operation. All this will be decided by the timer mode register. So you just see here tmod register value. What is my tmod register value, ma? What is my tmod register value? Ansuri, at least tell this. What is tmod register value? Tmod equal to what is the value, ma?
0, 1, ma'am.
0, 1. Very good. So T mod is 0, 1. We will see how this TL naught, TH naught value will be loaded. Okay, this is by creating the time delay only. So T mod value is 0, 1. Okay, we will see rest of the thing how it is working. So T mod is 0, 1. So T mod is 0, 1 means you have to understand mode 1 is selected, because 0, 1 means what, ma? All the upper part is 0, upper nibble is 0, lower nibble, what is the value? 0, 0, 0, 1. So 0, 1 means what? Which mode has to be selected? Mode 1 has to be selected, and I am going to, this lower nibble for timer 0 and upper nibble for timer 1. So I am going to use which timer, ma? Timer 0 I am going to use. Timer 0 is enabled, and similarly I am going to use which mode? Mode 1 operation. We all have to know. I think this is a recall which this you have studied already in the first unit itself. So people try to understand. Here you have 4 modes of operation: 0, 0, 0, 1, 1, 0, 1, 1. We all know 2 bits na 4 combinations will be there. So mode 0 na 13-bit timer. Mode 1 na 16-bit timer. Mode 2 na 8-bit auto reload, and mode 3 na split timer. You always remember, for creating the time delay we always prefer mode 1. Mode 1 is especially for to create the 16-bit timer in the program. 13-bit timer na you have seen 0, 0 to 1N, 1FF. I think see 0, 0 to 1FF. That means only 13-bit timer is used. So mode 1 16-bit. 16-bit means we all know the minimum value is 0, 0, 0 and maximum value is what, ma? FFF. That is 16-bit timer. 8-bit auto. 8-bit means first initially the value will be stored in higher order byte. Okay. Initially the value will be stored in higher order byte, that is TH, and then it will load in the lower order byte, that is 8-bit auto reload. So TH and TL will work parallelly, but split mode means TH and TL will be divided and it works separately, and this is what will work separately. So both 8-bit timer will work it separately. Okay, so you understand that. Now we are going to work which mode, ma? T mod 01 means what? Timer 0 is enabled, and which mode is enabled? Mode 1 is enabled. So mode 1 means what? 16-bit timer we are going to enable. Okay. Now this TCON register, I will tell you in the TCON register why I am saying na, we have put 2 flags for that: TF, TR. Okay, TF naught, TR naught. TF naught means timer 0 overflow flag. TR0 means enable the timer 0. So this 2 flag only we are going to use in this. That's why I use the TCON register. But in the program, we are not specifying any TCON register. But this TCON register is used to control the timer operation. Timer for TF0 for what? Timer 0 overflow. TR0 means for what? Enable the timer 0. Okay. Then now this is very, very important. Actually, in our lab, in our assignment, I have asked one question. I think no one have cross-verified me. I asked you to create 1 millisecond time delay using a timer. I think you searched it in the net and you have put it. But this is the step. People, please listen. How to create the time delay program using timer registers. Okay. So you all understand. This is the sort of procedure. Okay. Now, NNN, this is time delay. I have to divide the time delay by 1.085. Anyone tell what is this 1.085 microsecond, ma? What is this 1.085 microsecond? Anyone tell? Jayashree, what is this 1.085 microsecond, ma?
Ma'am?
What is 1.085 microsecond? What is the clock frequency? Here we are keeping all the way. We don't know what is this 1.805. At least I will show this. You can't see. What is the clock select we will keep, ma? 12 megahertz frequency we will keep. Am I correct or not? So what is the time period? How will you calculate the time period from the frequency?
1 by F, ma'am.
1 by F. So 1 by 12 megahertz is nothing but 1.085 microsecond. Are you clear? So put your mic in mute, ma. So
Okay.
now we are going to fix this time delay. Actually, in my program, I am going to create 15 microsecond time delay. So time delay, I have to fix it here. Time delay divided by clock frequency. What is the clock? Because we are not going to keep any external clock frequency. We are going to take the internal clock frequency only, because we have put that gate value also 0. So internal clock now 12 megahertz. So free time period is 1.085 microsecond. So NNN is equal to time delay by 1.085 microsecond. Now you see the value. I have to calculate how the value. Now subtract the resultant value from, actually FFFF means what is the equivalent decimal value here? 65,536 locations in decimal. But in hexadecimal, how we will represent? FFFF. Or else we will simply say the value is what, ma? We used to say it is a 64 kb. So this is the way we used to say 64 kb we will say, or FFFF we will say, but actually in decimal what is the value? 65,536. So you subtract the so from that you have to calculate NN value, and from that you have to calculate MM. In the MM value we are getting in decimal now. You have to convert that value in a hexadecimal. So you will get some 4 digit. In the 4 digit we all know timer have a 2 register. Okay, TH, TL as a timer 0, TH not, TL not for timer 0 register, TH1, TL1 for timer 1 register. Okay, so here that x-axis is higher order byte. You have to load it in timer higher order byte register. YY is nothing but I have to load it in lower order byte. Are you clear, ma? So this is the way. So first I have to fix what is the time delay I have to create in the program. Then I have to subtract from my maximum value. Why? I have selected mode 1. So mode 1, my maximum value is FFF. Because that much time it has to be executed. So then I have to convert the given decimal into hexadecimal. Then I have to load my higher order byte in TH and my lower order byte in YY. Okay. Now you people kindly have the look. NNN that I am calculating. 15 microsecond divided, because what is the time delay I'm going to select my here? Why I'm going to calculate 15 microsecond. Actually, in this case, I'm not going to create a time delay of 1 millisecond. Actually, I'm going to create 15 microsecond. So 15 microsecond time delay I'm going to calculate now. So 15 microsecond divided by clock frequency. That was 13. So that 13 I have to subtract from maximum value. So what is the value I'm getting? 65,522. That I have to convert into hexadecimal. So what is the value I'm getting, ma? FFF2. So FF must be loaded in TH and F2 must be loaded in TL. Now you go to your time delay program. I think you people have understand that. TL, F2, FF. Why I put TL not, TH not, ma? TL not, TH not means what? That is for timer 0. Okay. Now, how to create the time delay in the program? Set B TR not, I think. Once again, wait, ma. Okay. Now I think you can be able to see well. Okay. Now, TF not. We all know TF not means what? Timer 0 overflow flag. How the timer 0 overflow flag is working? I think, did you remember this PPT, ma? I think I have put it in first unit itself. How my timer is working. Okay, you just see whether I have to select my internal clock frequency or external clock frequency. Okay, so then prescaler. Prescaler means I have to divide by the value. Then timer. Here timer 0 is enabled. How the timer 0 is enabled? By enabling T or not bit, the timer 0 is enabled. Now the timer will count. We all know we are loading FF, F2. So the timer will count. So it will count for 16 bit. Because it is in which mode of operation? Mode 1 operation. You have seen this timer will count. So when the timer count, entire count is over, then see overflow flag will set. The TF naught will be set. Then automatically it will interrupt the enable. Then the particular thing will be enabled and the operation will be. Actually, here we are not going for interrupt. We are stopped here itself. Here timer overflow itself we have stopped. Can you understand? It's a continuation of the timer program. So now you come to our main program. Okay. So it's a very important timer program. You just see move tmod #01. That means what? Timer 0, mode 1 is enabled. Then th naught. So here ma, what do you have understand? Here timer 0. Okay, timer 0, mode 1 is enabled. That you have to understand. Are you clear? Timer 0, mode 1 is enabled. Okay. This is value. TH naught is what ma? FF. TL naught is what? F2. That means what? It is creating 15 microsecond time delay. It is creating what ma? 15 microsecond time delay. Okay. The next instruction. Okay. Then set B TR naught. That means what? Timer 0 is enabled. Okay. Now JNB. JNB means what ma? Neetu Priya. JNB means what?
Jump no.
Jump no?
1 second, ma'am.
Ma'am,
Ah.
jump no borrow, ma'am.
Borrow. Hey.
Bit, ma'am. Bit, ma'am.
Bit. Jump no bit. That means till TF naught is 0, it will check. Till TF naught. Jump no bit. That means what is the value we have loaded for TH naught and TL naught? What is the value I have loaded, ma? FF here and F2 here. So this is my TL naught value and this is what ma? My TH naught value. So what happened means it will keep on counting. Timer means what? It is used to create. So we don't need not to put decrement and all. The timer will ask to create. So every time I have to check. Once the count becomes 0, 0. Once the count becomes 0, 0 means what? The entire count becomes 0, 0. The TF naught value will become what ma? Jump on no bit. Jump on no bit means I am checking till TF naught is 1. So till this condition TF naught is 0. But once it reaches 0, 0, 0, the TF naught value will become 1. So automatically what happens? It will exit the loop. So when it exits the loop, once again what I have to do? I have to clear the TR naught and that means timer 0 is disabled and then I have to clear the TF naught. That means TF naught is also become 0 and return. Return means what? Once again it will come back to the main program. Once again it will come back to the main program. Have you understand? So one thing you have to understand, this is the timer programming mainly used to create the time delay. How much time delay I am creating through this ma? How much time delay I am creating? I have now only have told you how much time delay I am creating.
1.0
microsecond.
15 microsecond. Very good. 15 microsecond. So now I have given one assignment for you. I asked to create what ma? 1 millisecond. So the same program only you have to write. You have to write that, but TL naught and TH naught value will be changed. Am I correct or not? So how it will be changed, ma? You just go to this program. Here I have to create 1 millisecond. So 1 millisecond divided by 1.085 microsecond. Okay. You have to calculate n value. Anyone having calculator? Kindly tell me the answer. Kindly tell me.
0.921, ma'am.
Huh?
0.921.
0.921. 1 millisecond. No, ma, you are saying wrong. Microsecond is there. Hmm? Anyone have calculated, ma?
921.65, ma'am.
9, once again, I will see. 9216, very good. 9216. Okay. So 9216 now I have to subtract from what ma? 655 36. I have to subtract. What is my value after 9216? After my division, what will be the value? What is this value, ma? What is this mm value? 56320. Are you getting this value? 56320. That I have to convert into hexadecimal. So once I have to convert into hexadecimal. So what is the value I have calculated? 56320. Convert into hexadecimal na. What is the answer, ma? DC.
DC00, ma'am.
Very good, very good. So what is my TH value? DC, and what is my TL value? 00. That is the thing. I think one or two value we have missed, but this is the way to calculate. So the same program only you have to write. Are you clear? This is the same. Actually, whatever questions I gave you for you, all are university questions only. I've taken from the university question paper and gave you. So here, what do you have to put instead of? Actually, these are all I've scribbled. So here, what I have to put, ma? Here I have to put 00. Here I have to put DC. That is the only change in the program, and this the entire program you have to write. Are you clear, ma? Okay. I think now I have explained you how to create that and all. Next, I will explain the software for you. Okay. I think, I think you can able to see the screen, ma? Is it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
See, this is the Kale software, ma. Actually, this software only you are going to use. So today, what I do decided to explain this Kale as well as actually what is the time 11:35. So I will try to explain the Kale and Proteus. I think I won't explain you the procedure and all, because while doing the lab you will learn how to do the procedure and all. So if I want to, I have to create the project. If I want to create the new project, I have to create my project name. So I have created my project name as a project and my file name as a add.asm. So you have seen that now I have to translate my file and I have to build and I have to rebuild. Okay. So this is using Kale software. Okay. I have written 8-bit addition program. Okay. Bhavana, do you remember, ma? In 8-bit addition, what is this program? I am adding my accumulator content with R1 content.
R1.
Okay. After that, my result, where I am storing my result, ma?
Accumulator, ma'am.
Accumulator content is moved out to
Port 0, ma'am.
port 0. So the accumulator content. So I am going to view my result in port 0. Okay. So you will see, and you have to understand that. So first, I have run my program. After running, I have to debug my session. Okay, you have seen that. You have seen running with code size limit is 2 kilobytes. So I think I have told you have a on-chip memory and it will specify how much memory I will take for the running the code. Okay. So here, can you able to see what is this R0 to R7 or nothing but my bank registers, accumulator, B register, stack pointer, data pointer, program counter, and program status word and all. Okay. So now I am going to execute. Just see what is my accumulator value actually. Okay. What is my accumulator value, ma? Actually, wait, it is executing all the program which I will remove it, ma. Because I have loaded some more programs. I think it is executing all. Now I will execute. Okay, now you people have seen this shows the entire registers content here. I think it is not showing any timer and control registers that we have a specific way to view, but we have here we can see all the general purpose registers as well as the bank registers we can see. So these are the general purpose registers we have seen that. So now I am going to do step by step execution. So you just see now accumulator is A5. You are see my accumulator value is what more A5. Then I am moving my R1 is 4. I have asked one question in assignment. Default it will take which thing? Can you able to hear my voice, ma?
Yes, ma'am.
Okay, I think once again. Now can you able to hear, ma'am? It is echoing on. Hello? Yes, ma'am. So people is that I think the voice is not audible. Okay, wait. Okay. So please listen, ma. So accumulator is A5 and R1 is 4E. Now I am add A, comma 41. So adding A and 41, you just see what is the answer I am getting, ma? F3. So F3, my accumulator value is F3. But I am storing my value in where, ma? Port 0. So if I am loading my port 0, you just see peripherals, interrupt, IO ports, serial communication, timer 0, timer 1. That's why we have seen timer 0, we have taken TL0 and TH0. Timer 1, TH1 and TL1. So in the IO ports, I am going to take port 0. So you just see here, I am moving my accumulator content to port 0. So after that, you see, I have seen this is my port 0 content. I already told whenever the bit is 1, the tick will be available. If the bit value is 0, that is an empty space and it consisting of F3. Are you clear? So this is the way I can see my answer in port 0. Actually, this is a software, but you can see that how we can view the outputs and all. Okay, so this is a one simple program I have taken. So same program, instead of add, if I put sub B, okay, I think it will subtract, and we will assume this will we will load it in port 2. Okay, so once we have to debug the operation. So once we are debugging, you just see step by step execution. So first accumulator is what, ma? A5. Then R1 is what? 4E. Then subtract A comma R1. I have subtracted A5 minus 4E. So what is my accumulator content? 57. So 57 I am going to move in which register, ma? Port 2 register. So peripherals, you go to IO port and go and see my port 2 content also will become 57. It's not moving. Wait, I will see what's the problem. Shiva Subramanian, mute your mic.
Yes, ma'am.
So I have loaded A with A5, R1 with 4E. I subtracted and I am moving my accumulator content to port 2. Okay, you can see what is my port 2 banner? 57. So that is loaded in accumulator. The same content is moved to 57. So 57 now, what is the value? 0, 1, 0, 1, 0, 1, 1, 1. Are you clear? Can you able to understand? Okay. So this is we have seen one simple program. I think I will remove this program. I'm not telling any procedure and whatever I said that how it is working only we will see. Procedure we will see later. So next I am going to do uh, division program. Okay, so div. I'm going to add my division program. So you just see, we all know. So previous case, I have seen how to load, we have seen the output in ports. That's why I have taken the port commands. Port in peripherals, I have taken the ports. But now we are going to load it in internal memory. I think this program, what is my accumulator value of 5? What is my B register value? 2. Div AB, we all know div A by B, 5 divided by 2. And move R0 comma hash 60. R0 is 60. Move at means what? Indirect addressing mode. I am moving my accumulator value. So accumulator will always hold the quotient and B register will always hold the remainder. So we will see my in 60th location accumulator will store the quotient and INC. INC means what? Increment the R0 register. 60 will become 61 and then in the 61 location we will store the B register value. B register value means what? The remainder. Okay. So now we will execute the program. Once we will executing, we will. Okay. Now, see people listen. We are going to see in the internal memory. So we have a option to view memory windows also here. So view, you have a memory window option. So here internal memory I colon, what is the address is given ma? 60. This is the address I am going to store back my value. So 60H. You have to put 60H. Okay. Now accumulator is 5. You just see accumulator is 5. Okay. Then after accumulator, I am going to load in which register ma? B register. So B register is what? 2. Okay. Now what is the next instruction I am going to do? Div AB. Div AB means what? 5 divided by 2. So accumulator will store the quotient and B will store the remainder. So what is my accumulator value? 2. And what is my B register value? 1. Okay, quotient is 2 and remainder is 1. So you just see quotient is 2. Accumulator store the quotient and B register will store the remainder 1. Okay. After that, I am move R0 comma H. So R0 value is what? 60. Move at R0 comma A. What is at symbol ma? Anyone tell? Why we are using at?
Indirect address.
Indirect addressing mode. So in indirect addressing mode, if I put at R0, then automatically the accumulator will go and store it in 60th memory location. So if I execute that, okay, you just see in the down memory window. Can you able to see the memory window, ma? Can you able to see the memory window? Yeah. So memory window 2, accumulator will store the remainder in first memory location. Then INC R0. INC means what? Increment. Increment means R0 will become 61. Then move at R0, move A comma B. A comma B means what? I don't have any instruction. Directly move from B register to register bank. So I am using accumulator. So first I am move my remainder value to accumulator. So then now accumulator is 1. Now move at R0 comma A. At R0 comma A means what? I have to move my remainder to next memory location. So next memory location you are seeing, this is my quotient and this is my remainder. Can you understand? So first program we have seen how to store in ports and next program we have seen how to store in the address and some other program we can directly store in registers also. Are you clear? So we can store my results in accumulator. We all know always after arithmetic and logical operation, the accumulator will store the result. And the next one is we have a probability to store it in ports, or else we can store it in the internal memory location, or else I can store in my results in my bank register from R0 to R7. Okay. And we all know defaultly it will take which register, which bank? Bank 0. In PSW, if I put ZBP 3. PSW 0.4, that is the fourth bit and third bit is used to select the bank registers. Okay. Then this program is over. Then one more program, I think I will remove this. Complement.asm. I think, Can anyone explain this program? Can anyone explain, ma? It's not very difficult. We have already explained the program only. This is I have explained. Huh? Can anyone explain? Please, ma. Even if you are wrong, I will. Can anyone explain? Nandini? Sneha, can you build
FF move to the accumulator.
Okay.
And 10 move to the register.
R3.
And again 2 move to the R2.
Okay.
And complement A.
Complement A means what? FF will become what?
0,
Zero,
ma'am.
ma'am.
0, 0. Very good. Okay. Then.
And 0, 0 move to the P2.
Very good. Then.
Decrement jump no 0. R2, ma'am.
Actually, how much time this loop will be executed, ma? Outer loop and inner loop are there. How much time it will be executed?
10 times
20.
10 into
2.
2.
20
So totally
times.
how many times?
20.
20 times it will be executed. Can you understand? So the accumulator will be complemented. This is nothing but DJNZ means decrement, jump on no 0, it will keep on executing. Okay. So now we will see how it is working. Okay. So first I have to run my program. Okay. Then I have to. So which port I have used? Port 2. I have taken port 2. So now we will see step by step execution. So now what is accumulator value? FR. Okay. Then R3 is what? 10. 10 means in hexadecimal the value is A. Okay. Because if I put 10H only, it will take hexa value. Otherwise, it will take the decimal value. Then R2 is 2. Okay. Complement A. Complement A means what? Accumulator will become 0, 0. Okay. Then that value I am moving to where? Port 2. Then DJNZ. So every time what happened? R2 will decrement. You will see R2 is decrement. Have you seen? See, the loop is keep on executing. So if I keep on executing every time, how much time it will complement now? It will take some 20 times to complement. After 20th time, it will stop complementing. Are you clear? But here we are given, here just jump here. So automatically once again, my program will go to the main. So you people have to understand, if I give this, automatically it will execute. So this is for step by step execution. And this will give an entire execution. So you can see this execution. So after 20th time, it will stop complementing. Can you able to understand the program? So this is the experiment that I have explained in a logical programming. I have explained this program. Okay, now. So these programs we have already discussed. So yesterday we have discussed some interfacing programs. So today I tried to cover only the stepper motor program. Okay, so I will remove this program. This is every time I have to add the program. So procedure I am not explaining you. I told you how it is working alone. You just see. So stepper motor program. Okay. So you have seen that stepper motor program. You just see down mark. Can you able to see assembling 0 errors 0 1. Then built. After program size is there and creating hex file because we are going to load it in Proteus software. So we have created the hex file. Then we have rebuilt. So all the procedures are over. I think this program I have explained you yesterday. RRA, actually stepper motor we have created on two-phase on scheme, and at a time two-phase will on 66, 33, 99 cc. So RRA, RLA. So to rotate in one direction and to rotate in opposite direction, we used RLA instruction. Okay. So people, I will share one more software. Okay. Here you see, this is my microcontroller, and this is, I told you, ULN 2003 driver, stepper motor, supply. Okay, and I have connected this connection by seeing the diagram you can connect. So here what I am going to do, I am going to load my hexadecimal. This is my hex program I have created there. So that hex program I am loading in the microcontroller. Now it's nothing but it's simple. You just see it's rotating in steps. Okay. So now in this program, I have rotated. So if I want to increase the speed of the program, okay, can you understand? If I want to increase the speed of the program, what is the change in the program? What is the change in the program? Anyone tell? There some motor is rotating in one way. If you want to change the speed, what I have to do? What is the change in this program? Please, anyone tell? Where I have to change the value?
RLA, ma'am.
Yeah, that is for changing the rotation. RRA, RLA is used. But change the speed of the program. What is this program? Delay program. So if I change my value, here 100 means in decimal it is taking 100. Okay, 100 means we all know in hexadecimal it is 64. Now I am going to keep the maximum value 0 FF, and here also 0 FF. Okay, so now I am going to execute. So you just see how the speed of the program is going to be changed. I have to stop because I have to reload my file. Once again, I have to go and I have to reload. Okay. Now, it's rotating in same speed. Wait. Actually, there is a error here. Error A1. Illegal. We put 0 FF hex. Okay. Then 0 FF hex. What is the mistake I did, ma? I didn't put hex, H. So what it think? It takes, I think, as a decimal value, but decimal we don't have a F. So that's why it thrown there as an error. I didn't check that while throwing the error. Okay. Now we have see. Okay. Now once again we will upload the same program. LED1 X. Okay. Now you have seen whether my motor is rotating, ma? How it changes the speed of the rotation? How it is changing, ma? Kavita, how it is changing the speed of the rotation? Kavita, are you here?
Yes, ma'am.
Just
How it is changing the speed, ma?
To
By
change the FF.
by changing the time delay. If I increase the time delay, automatically what happens? The speed of the rotation is changed. So the time delay play a vital role by changing the speed. Okay. Now one have asked, ma'am, if I want to change the rotation of the thing. Okay. So instead of RRA, what I have to put? RLA. Okay. So I will put same 100. Okay. Here also 100. Now you see, I have executed my program. After executing, once again I will share my Oh my God. Actually, proteins. The particular microvision. Yeah. Now I am sharing. So I will stop. Once again, I will load my, because I have changed the rotation of the program. So once again, I am loading, and once again, I am running. Now you see, now it is rotating in which direction, ma? Clockwise direction. So RRA and RLA will change the rotation of the program, and the time delay will change the speed of the rotation of the motor. Can you understand? So if you understand and correlate, it is easy for you to do the programming. Okay, I think now I will take the attendance from you people, and Tyagi is present today. Tyagi and Harshavardhan. Which Harshavardhan submitted? Register number 7 or 37? Who have submitted the? Who have submitted, ma? Who have submitted the assignment? But only 2 people's assignments are in draft. So please inform us to say. I think now I will stop share, ma. Now I am going to take the attendance. Okay. So people, by seeing your number, I have a, I think I will ask. Register number 1 is present. Okay. 2 present. 2, Abhirami. Abhirami, are you present? 2 is not there, ma. Absent.
Absent, ma'am.
3 present. 4, 5, 6 present. 7, 8, 9. Register number 9. Angelina. Angelina Aishwarya is absent today. Okay. 10 is present.
Ma'am, my roll number is 8. My
Who
registration.
is 9? Anurag. Anurag. Okay. 8 is present. 9 is absent. Okay. 10 is absent. Sorry, 9 is absent. Still, I have shown how long you are taking the leave. The attendance will be reduced, ma. 11, 12, 13, 14, 15, 16. 17 is Bibu Anant is absent today. Okay, absent. 18, 19, 19. Sushant is absent today.
No, I'm present, ma'am.
Sushant, you
Present.
didn't number it properly. Okay. You are present only. 20, 21, 22.
Forward.
23 is present, 24 present, 25 present, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36 is absent. Okay, present. Second present. Okay, 37, 38, 39, 40 present, 41 present, 42, 43, 44 all present, 45 present, 46 is absent. Kausalya is absent. Okay. 47 present, 48 is absent, 49 present, 50 present, 51 present, 52 present, 53 present, 54 present, 55, 56 are present. 57 present, 58 present, 59 present, 59 is, no 59, 59 is there, present, 60 present, 61 present, 62, 63, 64, 65, 66, 67 present, 69 present, 70, 68 Rajamanikam, 68 Rajamanikam absent, 69 present, 70 present, 71, 72, 73, 74, 76%, 77%, 78, 80%, 81%, 82%, 83%, 85%, 85%, and 86 Surya Prakash percent.
86
Sundarajan. Sundarajan present. 87 Surya Prakash percent. 88%, 89%, 90%, 91%, 92%, 93%, 94%, Shanmuga present, Ramkumar present, Maunika present. Okay. Then Izad Ahmad is also absent today.
Present, ma'am.
Okay. Where is, okay, Izad is present. Okay. Shah Vijay Kumar? Vijay Kumar is absent. Okay, ma. See, please understand only 40 students have submitted. Only one day is more. So even for other students also, they have to submit on tomorrow. So kindly find your time and submit it. Are you clear? Okay. I will stop recording.